Hello everyone, Mr. Minix my name, math is my game. Today in Algebra 2, I'm joined by my favorite Algebra 2 class. We're all really excited because it's a 4-day week. The title of this section is the standard form of a quadratic function. For some reason, I just had a flashback to my 7th grade math class. I had a teacher by the name of Mrs. Cenarius, and she had that really thick Cleveland accent. Do y'all know what I'm talking about? I'm sorry if that's driving you nuts. There we go. My smart board. I was trying to shake it up so I could get all that to be one contiguous object there. There we go. The standard form of a quadratic function. The beginning of this is going to seem a little bit unusual, but that's okay. Who doesn't love Batman? I mean, Batman is great, isn't it? So I'm going to cut out part of the bat symbol. There we go. There's part of the bat symbol. And then I need to do a Google search for Batman. And there's a certain Batman that I'm looking for. I think that's the one, but I don't know. I actually had a math professor who reminded me of Adam West of that Batman. Well, I think I'm just going to have to put the name in. There we go. I like this Batman. Anybody ever see this Batman? He's my favorite. I know some people like Christian Bale, but I like this one. Okay, so we got that Batman. And then there's another Batman, or, this guy shows up another way. There we go. Maybe you've seen this movie. I bet somebody in here's seen it. I bet somebody in here's seen it. So you're probably thinking, what in the world does Batman and Beetlejuice have to do with today's lesson? Maybe you'll figure it out. Here we go. The other day ago we saw this, y equals a times the group of x minus h, the group squared, plus k. And that's kind of like Batman. And today we're going to see y equals ax squared plus bx plus c. And that's kind of like Beetlejuice. And on Wednesday, we get to see another form of that person. So you saw that the guy's name is Michael Keaton, right? Michael Keaton is common to both characters, right? So if we relate this to the title of Chapter 4, Section 2, we could think of Michael Keaton as what? As a superhero, as a constant, as a werewolf? No. Well, let's just go ahead and let's skip ahead to. I'll go ahead and write this because you're probably thinking, what the heck is he talking about? Let's just look at Michael Keaton. Michael Keaton. Michael Keaton. He's an actor. Let's just look at him when it's just him. There we go. There he is. So there's Michael Keaton. Okay, so maybe it would be better off like that. And then what we're going to look at Wednesday is going to look like this. Y equals a times x minus p times x minus q. Okay. So the point is there's something common to all of them, all of them are Michael Keaton, but each one is a different form of Michael Keaton, right? Well, down here, this is a different form of what? This is a different form of what? This, thank you, of a quadratic equation or quadratic function. Okay, so we're talking about quadratic functions, and sometimes they appear in different forms. Everybody see where I'm going with that? I'm sorry, that took longer to develop than it should have. One thing I want to be redundant about, and I know redundant's one of those weird words. It's one of those odd words. It's one of those words that's different. It's one of those words that's unique. It's one of those words that's unusual. What does redundant mean? Repeating, saying something over and over and over again. So I'm going to say this. I'm going to say A is A is A. I know that seems really weird, but I want to look at the A in all three forms of this, and I want you to realize that this A right here that we talked about last week is the same as this A right here that we're going to talk about today, and it's the same as this A right here that we're going to talk about on Wednesday. So when we had notes over chapter 4, section 1, we said we could say 17,000 things about A, but I think we said about 6 things about A. What were some of them? A is not 0, good. So A is not allowed to equal 0 because if it is, we don't have a quadratic. What else? Yeah. It's the coefficient of x squared, good. What else can we say about A? Yes. If A is less than 0, then the graph opens down and has a maximum. Good. What else? What do we got? Oh, that's the one I was looking for. From the vertex. From the vertex, we go over 1, and then up or down A units. I like that one. That's my favorite one. I'm so excited about that one. I almost got dyslexic there when I went to write that. When we go from the vertex, we go over 1 unit and then up or down A units. And we always do that. And that's how we go about graphing these things. That's how we go about graphing these things. So we could say more about A. We could say that if the absolute value of A is bigger than 1, we have a vertical stretch. If the absolute value of A is between 0 and 1, we have a vertical compression. So I want to back that thing up for a minute. Can we do that? Let's go to example 0. This is from last week. Example 0, we're going to try to graph y equals, this is example 0.1. Graph y equals x squared. Y equals 1x squared. Okay. So where's my vertex on this one? 0, 0, good. So there's my vertex at the origin. And then remember what we said about the A value. The A value says, my A value is 1 here. The A value says we're going to go over 1. It says we're going to go over 1. We always go over 1. Always says we go over 1 and then up or down A units, right? So over 1 and up how far? Or down how far? Over 1 and up 1, right? And for math Excel purposes, that was enough, and that could have gotten us our graph. We doing okay so far? On the same graph, let's go ahead. So our vertex there was at the origin at 0, 0. On the same graph, let's try to graph y equals 3x squared. Where's my vertex going to be on this one? My vertex on this one's going to be at 0, 0 again. So my vertex on this one's going to be at 0, 0. And now, if I look at my A value, A says from the vertex, go over 1 and up A. Well, so my A value here is 3. So this time, I'm still going over 1, but now I'm going to do what? Up 3. So over 1 and up 3. 1, 2, 3. So when I graph this one, it's going to look like that, right? Let's try one more. Y equals negative 1/8 x squared. That's negative 1/8 x squared. Where's my vertex on this one? 0, 0 again. One more time, vertex is at 0, 0. And now my A value is 1/8, so what am I going to do? Down 1/8, but how far over? Over 1. We always go over 1 and down 1/8. 1/8 is half of a half, so actually 1/8 is half of a fourth, so it's not that far down. But anyway, so we do that, and then this graph is going to be a vertical compression and something like that. How do we go over 1? We always go over 1. If we don't go over 1, no, that's fine. There's a big question here. We sure? Okay. Hopefully we'll be able to see what happens when we go over more than just 1. Hopefully we'll get to some of those. Okay, let's try example 0.2. Example 0.2. This time let's try to graph y equals -8 times the group of x plus 1, the group squared, plus 10. Oh, it's magic. Hey, somebody knows that song. Good. Oh, so where's our vertex at? -110 is where our vertex is. Now this part confuses a lot of people, so we need to back that thing up for a second. Remember, vertex form is y equals a times the group of x minus h, the quantity squared plus k, where our vertex has coordinates hk. Right now, while we're doing this live, the sun's kind of blinding the screen a little bit, but h, remember what we said about h. It's counterintuitive. It's the opposite of what you think. So what we've got going on in this example 0.1, the vertex is -110. One way you could think of it is this way. I keep saying I'm going to make a video about thinking about it, just like they have a video about looking at it. I want to make a video about thinking about it. But we could have written this as y equals -8 times x minus 1 squared plus 10. And from that perspective, then, I think it's pretty clear that the x-coordinate of the vertex is -1. Is everybody good with that? Okay. So I'm going to go ahead and plot my vertex. I'm going to go ahead and plot my vertex right there. There's my vertex at -1, comma, I said -1, comma 10. And here's where people don't like me anymore. Here's where people say, Mr. Minnick, you shouldn't have done that. Because I was right on board with you, and now all of a sudden, I don't know what you're doing. Why are you covering up that plus 10? Why are you covering up that plus 1? Why are you doing all that, Mr. Minnick? Well, because I can. I don't need it. Now all I got to do is graph what? The -8x squared. So now we're going to graph y equals, I said y equals -8x squared from our vertex. Once we get our vertex, we know how to graph this. So what do? Over 1 and down 8? Good, yeah, over 1 and down 8. Nice, good. So from the vertex, over 1 and down 1, 2, 3, 4, 5, 6, 7, 8. So right there and right there, and that's how we do. How's everybody feeling about this? Is it making sense? Everybody on board? Good. I feel pretty good about this so far. Okay. Example 1. Find the vertex of each. Find the vertex of each. We're going to look at example 1, number A. I know A is not a number, but it is today. Example 1, number B. Example 1, number C. Example 1, number D. And number E. Thursday's quiz, you're going to have to do this. Y equals 6 minus x squared. Y plus 7 equals 3 minus the group of x plus 1, the quantity squared. Y equals x squared minus 4x. Y equals x squared plus 6x minus 1. Y equals 13x squared plus 54x minus 9. believe it or not, the first two, the vertex isn't too bad to find. The vertex isn't too bad to find. What do we think on the first one? The first one's 0, 0. It's actually not 0, 0. It's almost in vertex form, but some things kind of need, somebody said it, 0, 6. The first one, the vertex, is 0, 6. Okay, 0, 6. The reason for that is we would really need to kind of modify that equation just a little bit and jockey some things around. We could think of it as y equals negative x squared plus 6. So there's no parentheses, nothing going on inside parentheses, which means the x coordinate of the vertex is 0 on that one. Okay. Now the next one's a little bit sneaky. A little bit sneaky. What do we think? Negative 1, 3 is a good try. I like the negative 1. That's a good start. The negative 1's right. Negative 1, negative 1, negative 7. Negative 1, negative 4 is what we're looking for on this one. Negative 1, negative 4. The deal on this next one, on number B here, the deal on number B is we need to jockey some things around, so we need to bring this plus 7 over to this side of the equation. Everybody with me on that? Yeah, so you're going to subtract 7. So we would have y equals, and I'm going to go ahead and in this one, I'm going to go ahead and put this part of that first. Everybody see why? Because that puts it in vertex form. So y equals negative the group of x plus 1, the group squared. And then when I have 3 take away 7, that's going to give me negative 4. Okay? How's everybody feel so far? Good? Okay. Meow. The next one. Everybody think they know the vertex of that one? It's not 0, 4. It's not negative 4, 0. 1, 4, no. 0, 0, no. 1, 3, no. 1, negative 4, no. 1, 4, no. Let me see if I can break this apart. There we go. Oh, a smart board, and I like to fight sometimes. So number C, here's the vertex on this one. The vertex on number C, the vertex on this one is 2, negative 4. I'm not going to give it away just yet. I'm going to write up what the vertex is for number C, or for number D and for number E, and we're going to see if we can figure this out. For number D, the vertex is negative 3 something. Actually, negative 3, negative 10. Oh, man. I thought I had it. I thought I had it. Number E, I know E's not a number, but number E, the vertex, I honestly don't know the y coordinate of the vertex. The x coordinate of the vertex is this. It's negative 54 over 26. That actually would reduce. That actually would reduce. So that's going to reduce to negative 27 over 13. Something. You mean, so finding the vertex here is a little bit more challenging? Well, sure. In math class, when we can't find something, we need some kind of tool to add to our toolbox, right? So we're going to have 3 formulas. You ready for them? 3 formulas. Here we go. So standard form is y equals ax squared plus bx plus c, where a is not 0. To be real clear, a is x squared's coefficient, right? X squared's coefficient. X squared's coefficient. And b is the coefficient of x. B is X's coefficient. X's coefficient. And C has a special name. It's called C for a reason. Because it's never changing. Because it remains constant. Good. So C is called the constant. Okay. So do you remember what we talked about when we said the X coordinate of the vertex? What that was called? The X coordinate. The X coordinate of the vertex. What variable that was? What variable we used? Not B. Not H. H is the one. H is the one. So when we're talking about the X coordinate of the vertex, it's the variable H, right? So here's the formula for it. H is negative B divided by 2A. I'll go ahead and highlight that for you. H is negative B divided by 2A. You're going to be using that formula a lot tonight. A lot when you do the 4.2 Math Excel homework. So speaking of the Math Excel homework, when you do it, you're probably going to want some pencil and paper beside you because you're going to need to work some things out. I don't know if I'd work them out like the constipated mathematician did, but you are going to need to work some things out. Now, what did we say we used? What variable did we use for the y coordinate of the vertex? The y coordinate of the vertex is k. There's two different formulas for k. One of them is El Cheapo. Have I told you El Cheapo yet? Please don't think I'm insulting the intelligence of any Latin American people, because I'm not. But I'll write El Cheapo on your paper sometimes if you write an answer that's cheap, but it works. So here's what the book gives for the El Cheapo formula for k. They say k is f of h. That's El Cheapo. What they're saying here is instead of y equals all this, whoa, where'd you come from, Michael Keaton? That was kind of creepy. That was really creepy. Michael Keaton just kind of showed up out of nowhere. So instead of having y equals, suppose we had f of x equals. Okay, so all they're saying is to find k, you just plug h back into the original equation. So in other words, it would be ah squared plus b h plus c. You plug h back into the original equation in place of x, and that's how you find k. That's how your book tells you to do it. Houston, there's a problem with that one. There's two problems with that one that I see. One of the problems with that one, not that there's anything wrong with it, but one of the problems is this. If you mess up your h, you mess up your k too, right? Also, your k also. In addition to that, what happens if your h is a fraction? Then you're going to be dealing with a mess of fractions, right? So, you're welcome for this. This one's not in your textbook. You only see this in a pre-calculus textbook. Please don't try to simplify this formula. This formula cannot be simplified. This is the simplest form of it, but it does work. It's 4ac minus b squared divided by 4a. Some people try to cancel the 4 with the a, the 4a in the top with the 4a in the bottom. Don't cancel it. It doesn't work that way. And I'm sorry, my a's really look like 9s, especially when I put them in denominators. That's a 4a, not a 49. That's 4. That's 4a. 4a. Up top, that's a 4a also. We ready to try this? Put it into practice. Okay. So back here on example number C, I guess. On example number C. What in the world? Example number C. Let me just cut it out and put it on a clean page. I said it was 2 negative 4. See how I did. So what's our formula? H equals negative b over 2a. And k is 4ac minus b squared over 4a. Now, here's one problem with this. You have to be able to successfully identify a. and B and C. A is what? Nice. A is 1, and B is -4, and C is 0. Nice. C is 0. Okay. So let's see if we can find H. H is -B, so that's -4 divided by 2 times 1. So that's going to be 4 over 2, which is 2. Okay, that wasn't so bad. Plugging into the formula for K. K is 4 times A, so that's 4 times 1. What's up with the parentheses? Well, I like to use them. Times C times 0 minus B squared. Here's where people mess this formula up. You got to be careful on this formula. Minus B squared over 4 times A. So this formula, it's real easy to mess up. It's a nice formula if you know how to calculate with it. What's this whole quantity right there going to equal? 0. Good, I'm glad we know that. What about over here? I'm hearing 16. It's not 16. It's -16. When you square -4, that is 16. But that negative sign out front says take the opposite of that. Okay. So what's going to happen then, just to be clear, it's going to be 0 minus 16 in the top, and then in the bottom we get 4. So we get -16 over 4, which is -4. Okay. So when it's all said and done, then our vertex on this one is to -4. Doing good? Now I want you to be real clear on something. The fact that this -4 and this -4 worked out to be the same, totally a coincidence. Okay, so don't think that you can take this coefficient and it's always going to be that. It's totally coincidence that that worked out that way. Okay, that was just a mere coincidence. So let's work out number D, and let's see how this goes one more time. So working out number D, we're going to have H is -B over 2A. So that's going to be -6 over 2 times, what's my A? 1. So that's -6 over 2, which is -3. Do we want to try the other way of finding K? I do, and there's a reason for it. There's a reason for it. So I'm going to just plug this back in then in place of X, okay? And I'll show you something interesting that happens. So it's going to be -3, the quantity squared, plus 6 times -3 minus 1. Now, a very cool thing happens here. This term right here and this term right here. You see how those two terms are side by side? If you use this way to find K, what's going to happen is those two terms are going to have opposite signs, and one of them is going to be twice the size of the other one. So this does two different things. Number one, it tells you if you're on the way to get the right answer for K. And number two, it tells you if your H is right or not. That's going to happen every single time. These two terms are going to be double opposites. When I square -3, I get 9. That next term, what am I going to get? A -18. One of them is positive, one of them is negative. 18 is twice the size of 9. Make sense? That means my H is right, and I'm on the way to the right answer here. Yeah, good. So 9 minus 18 is -9 minus 1, and there we get -10. Do you have to use that way? No, you don't. No, you could have used the other technique. Would you get the same thing? Of course you would. K is 4 times A times C minus B squared over 4A. That's -4 minus 36 over 4. That's -40 over 4, and that's -10. It doesn't matter to me which way you use. There are benefits to each. Yeah, an advantage to using the f of x is as long as you know how to find h, you can find the other one. Yeah. Yeah. Now here's where there's a drawback to that one. So we'll call this example 2, I guess. Example 2, let's try to go ahead and graph something like this. Let's try to graph y equals x squared plus 3x minus 7. Now, one thing that I want to, no, I can't make that minus 7. I'm sorry. If this messes you up, I'm sorry. I'm going to make that minus 2 instead. Okay? Hopefully that doesn't throw you off too much. So let's go ahead and find our h. H is negative b over 2a. So that's going to be negative 3 over 2 times 1. Oh, it's a fraction. We okay with fractions? It happens. It's part of life. K is it's negative 3 halves, the quantity squared, plus 3 times negative 3 halves minus 2. Hopefully we can simplify this the right way. Squaring negative 3 halves is going to give us what? 9/4. Now this 3 is over 1. That's going to give us negative 9 halves, right? And then minus 2. Now, I need this fraction to have a common denominator to this fraction. So what am I going to use for my denominator? 4th. So I'm going to multiply this fraction by 2 over 2. So I'm going to have 9/4 take away how many fourths? Minus 18. Hey, one's positive, one's negative, and one's twice the size of the other one. Okay. What about the 2? I need to turn that into fourths. So I'm going to have to multiply 2 by 4/4. So that's going to make that minus 8/4. 9 minus 18 is negative 9/4. Take away 8/4. So how many fourths is that going to be? Negative 9 take away 8 more. Negative 17/4, huh? So my vertex, is negative 3 halves, negative 17/4. That's my vertex. We haven't even got to graphing it yet. We'll come back to that. So let's look at how the other way of finding K would have looked. K, we said, is 4 times A times C minus B squared over 4A. That's a parenthesis there. So that's going to be negative 8 minus 9 over 4. So that's negative 17 over 4. So maybe there is something to that formula. If you're dealing with fractions, it makes life a little easier, huh? But we haven't graphed this yet. But the good news is we know where our vertex is. The good news is we know where our vertex is. So our vertex, isn't that kind of like our starting point? Isn't that where we begin graphing this? So here comes my axis of symmetry. My axis of symmetry is going to be right there, right? Negative 17/4. Here's where it's nice to be able to convert an improper fraction to a mixed number. So my vertex, I can really think of my vertex as being at negative 1.5. Negative, what's that? Is that 4? 4 1/4? Okay. So 1, 2, 3, 4, and 1/4. So there's my vertex. There's my vertex at negative 3 halves, negative 17/4. Okay. What do I know about my A value? What was my A value? My A was 1, wasn't it? So from the vertex, I'm going to go over 1 and up 1. So over 1 and up 1 is going to put me right here. So that's going to be the point. And that was negative 1.5. So this is going to put me at negative a half. And then up 1 from negative 4 1/4 would put me at negative 3 1/4, right? Now there's one other point that Travis Gibson, shout out to Travis Gibson for noticing this. One other point that he noticed from the original equation. Anybody remember the definition of a y-intercept? It's where the graph crosses the y-axis, but what's the value of x there? It's not the h value, but we're onto something. It's not the k value, it's the c. A y-intercept is the value of y when x is 0. When x is 0, this x squared term goes away, right? And this plus 3x goes away, right? So that constant is our y-intercept. And in this case, it's -2. So our y-intercept is going to be -2. Okay? That's going to be our y-intercept. And that's one more point that we can get on the graph without doing much work. Okay. So by symmetry, I can go over here and up to here. So I could get the point Q, PQ. So that's at -1.5, -2, -2.5, comma, -3 1/4. And then by symmetry, I guess I would get this point over here. I would get this point over here. Oh, that was supposed to be -2. There it is. So it's going to be right there. Okay. And I tried putting 2 markers in the same tray. Didn't work out so good. Are there any questions, comments, concerns, short debates, long debates? So, some news about this section. Is it difficult? There's going to be some work involved, yeah. How did I get the x value for the what? Oh, this -2.5 here. This one? For the vertex? That came from the -b/2a again. That was way up here, this -b/2a. Oh, how do you find it the other way? There's really no other way to find it. That's it. That's it. Without using a calculator or randomly plugging things into a table and running into it by chance. Like noticing where the graph turns back around. Okay, good question. Any other questions, comments, concerns, short debates? If not, it's been real, it's been fun. I'm going to give a shout out to anybody who's watching this video. Goodbye.